The next section of chapter 1 talks about the importance of testing. The title is Why is testing necessary? Testing is necessary because when we do testing of components and system and their associated documentation can help reduce the risk of failures occurring during operation, and we as a tester measure the quality. When defects are detected and subsequently fixed, this contributes to the quality of the component and systems. Testing is important also because it may be required to meet contractual or legal requirements. We need to make sure that we are following the contract with the customer and there is no legal problem in our project. Throughout the history of computing, software systems are delivered into operation, and because of defect and failures and software does not do what it is intended to do, this makes stockholder and the client not happy. This is why we need testing. We apply the test technique to reduce the frequency of such problems. The problem will happen, but we need to reduce. How do we do this? By applying the appropriate test technique with the appropriate level of test expertise in the appropriate test level and at the appropriate point in the software development cycle. Let's take some example of having testing contribute to success of the project. If testers are involved in requirement review or user story refinement could detect defect in the work products. The identification and removal of requirements defect reduce the risk of incorrect or untestable functionality being developed. Another example is if the tester work closely with system designer, this increase both developer and tester understanding of the design and how to test it. When this is happen, it reduce the risk of design problem that happen in the software. Another example, if the tester work closely with developer while we are writing the code, this increase each party, the developer and the tester, understanding of the code and the way of testing it. This reduce the risk of defect and the code and the testing of it. If tester verify and validate the software prior to release can detect failures. This increase the likelihood that the software meets stakeholder needs and satisfy requirements. Let's now talk about quality assurance and testing. Quality assurance and testing are not the same, but they are related. Large concept quality management that tie them together. Quality management include all activities that direct and control an organization with regard to quality. Among other activities, quality management include both quality assurance and quality control. Quality assurance focus on the proper processing. We need to make sure that our process is done correctly. If the process is done correctly, the work product that is created by those process will have a higher quality. Also in QA, we use root cause analysis, which is identifying the cause of the defect. Why did this defect and those defects happen? We focus on the cause root and we try to solve it. If we solve the root cause, the defect will not happen in the future. Quality control cares about the product, the quality of the product. This is why it involves various activities. One of them is testing activities. So testing activities are the part of of the quality control and they are related to quality assurance. This activity is also the part of overall software development because testing is considered a part of development cycle from requirement gathering to development. And also this thing is part of maintenance process. After we delivering the customer if software and he has any complaint with we should do maintenance testing. We test the software again to make sure that there is no problem in it and there are any problem we should solve it. Since quality assurance gives about the execution of the process, then we can say that quality assurance helps support proper testing if the process is correct and of course testing is a part of the process. Then testing will be done in a better way. Let's now talk about error, defect and faults. Failure. A person can make error or mistake so we have developer he makes an error or mistake. This error or mistake can lead to a defect, fault, or bug in the software code or in the work product that we are doing. How can this happen? For example, we are gathering requirement. The product owner or the business analyst made an error. This error lead to a defect in the requirement. He wrote one requirement in our own way. This defect will goes a programming error that will lead to a defect in the code. So the error and the requirement elicitation leads to the defect in the code at the end. But what happened in the code is executed with the defects. This may cause a failure, but when this happens in all circumstances, no. Sometimes defect cause failure and sometimes no. For example, some defect require very specific input to cause failure to error happen. The first reason for error is time pressure. We don't have much time, so we do a lot of error or a lot of mistake. And second thing is human fallibility. We are human. We make mistakes. Third point from is some of the developers are not experienced enough, do not have experience in this field. So in this case, we think that error from them will increase. Miscommunication between project participants, including miscommunication about requirement and design. So the project participants are not communicating in the good way. This means that the person who is gathering a requirement does not deliver the requirement in a good way. So in this case, that the design may have problem, the coding also have problem. Complexity of the code and the design or the architecture we are working on a big project, a complex project. This way the likelihood of error will be increased. Misunderstanding about intra-system and inter-system interface. So if we don't understand these interface, error will be increased. New unfamiliar technology. We are working on a new technology that we are not familiar with this case. Our error will be increased. All of these reason are internal factor, but there is also external factor which are cause to failure. In addition to failures caused due to defects in the code, failure can be caused by environmental conditions. Things that we can control. For example, radiation, electromagnetic fields, and pollution can cause defect in firmware or influence the execution of software by changing hardware condition. In this condition, our project does not have any problem. Not all expected test results are failure. There is something called false positive. False positive means that you as a tester made a mistake. You execute your testing on your own way, or you enter some wrong testing data, or you use the test environment in wrong way. In this case, you might find a defect inside the software. But this defect is not a defect, this is a problem in your execution. On the other hand, false negatives means this is a defect that you should find but you didn't find. Why? Because you made mistake in execution of the testing. So false positive means this is no detect but you detected a defect because of your mistake. The root cause of defects are the earliest action that cause the defects. Like we said, we should analyze the defects to find the root cause so that this defect do not have again in the future. By focusing on root cause, analyzing leads to process improvement. We improve our process so this type of defect not happen in the future. For example, we have a problem that interest payment are not calculated correctly in our code and the customer is not happy. In this code, the defect code was written for a user story that was ambiguous. So, what is the reason of that problem? The reason of this is user story, the requirement. Who wrote the user story? The product owner. So, this problem in the interest calculation have been because of product owner doesn't not does not understand the field deeply, and we found that a lot of user story are written on way. So what is root cause? The root cause is misunderstanding of the product owner. Then what is the solution? The solution is to train the product owner on this field. So let him understand it in the better way and write a better user story. If we write a better story, the developer will write a appropriate code and the problem will not happen again in the future. Complaint that came from the customer is the effect. The incorrect interest payment or the failure. The wrong calculation in the code is defect which came from an original defect which is ambiguity of the user story. The root cause of the defect is the lack of knowledge on the part of the product owner, and the mistake is that he did while writing the user story.